So it's going to make it invariant. So the reciprocal of a function, right? I mean, we've done reciprocals before, reciprocals of numbers. Speaking of which, before we look at the reciprocal of a function and its graph, and how to graph a graph given a graph, how to graph the reciprocal from the graph, and there's actually just an easy way to do that. We're first going to look at the reciprocal of numbers, which is going to help us in being able to graph the reciprocal of a graph without having to get all the points and stuff, right? Because stuff happens. So what's the reciprocal of 1,000? 1,000. It's like counting seconds. 1,000, 1,000. What's the reciprocal of 1? 1. This is actually very important. As simple as it seems, it's very important. What's the reciprocal of 1/5? 5. This is also important. What's the reciprocal of 0? Undefined. That's also important. All of these apparently are important. Negative 0.002. Well, that's important. What's the reciprocal of negative 0.002? You can use your calculator if you like. We're going to go 1 divided by negative 0.002. Negative 500. So two things are important there. One, that it is negative. So taking the reciprocal will not change the sign. And two, that it's actually a pretty large number. What's the reciprocal of negative 1? Negative 1. That's also very important. What's the reciprocal of negative 1,000? Negative 1 over 1,000, or negative 1/1,000. That's also very important, right? We need these. It's not so obvious why. You say, why is it so, but we'll see, right? Because when we go to actually start drawing the graphs, and we'll say, well, what happens is you go out here and numbers get really, really large. I mean, if the number gets really, really large, then its reciprocal gets really, really small. And if the number is really, really small, then its reciprocal is really, really large. So use your answer from question 1 to complete the following statements. The reciprocal of a positive number is, well, the reciprocal of a negative number is. So we don't change the sign. Taking the reciprocal, we are not changing the sign of the number. If it's positive, then the reciprocal is positive, and if it's negative, the reciprocal is negative. The reciprocal of a small size number, 0.01 or negative 0.02, is a large number, whereas the reciprocal of a large size number, like 200 or negative 1,000, is a small number. The reciprocal of 0 is, and the reciprocals of blank and blank are invariant. Well, 1 and negative 1. Invariant means does not vary, does not change, right? Doesn't change. That's very important. Reciprocals of functions. For each function, state the zeros of the function, state the reciprocal of the function, and state the non-permissible values of the reciprocal. Okay, 2x plus 6. What is the 0? Which means what's the value of x that makes it 0? Yeah, which we would also call 6 divided by 2 is? Yeah, so here's what we're going to do, right? It's okay, so take your time doing this, right? It's not a big deal. You got to write it out, So what do we want? We want 2x plus 6 to equal 0. So then 2x is negative 6, x is negative 3. What's the reciprocal function for 2x plus 6? 1 over 2x plus 6, right? So the reciprocal function is just reciprocal. It's 1 over. Now, what are the non-permissible values of the reciprocal? Negative 3, right? Because negative 3 is the value that makes the original function 0, if the original function is 0, then it's in the denominator of the reciprocal function, and we know that it can't be 0, so the non-permissible value is x is equal to -3. If we write it as a restriction, we would say x cannot be equal to -3. So really, you know what? Let's change this to restriction. So what's the restriction? Right? So we'll say x cannot be equal to -3. That's a restriction. Okay, f of x is -x squared plus 3x. So what are we going to do? We're going to set -x squared plus 3x equal to 0, and we're going to solve that. How are we going to solve? Factor, sure. Before we factor, let's get rid of the negative. I don't like negatives, not leading negatives, right? So we could write this, x squared minus 3x is equal to 0. Multiply both sides by -1, right? You could also factor out a -1. X bracket x minus 3 is equal to 0. So the zeros are 0 and 3. Okay. So how you find those zeros is really up to you, right? I mean, I know I have to factor. I'm going to set it equal to 0. Once I've done that, I know that I can just go through and change the signs, right? So I don't have to worry about that -x. So I'm not factoring a -x. Okay, what's the reciprocal function? 1 over -x. So reciprocal function is really pretty easy, right? I mean, you're just going 1 divided by whatever the function was. And what are the restrictions of the reciprocal function? So it cannot equal, right? X cannot equal 0 or 3. X squared minus 2x minus 8. Okay, how are you going to get the zeros? Probably by factoring, right? Okay, so factor it. Once you factored it, check to make sure your factorization is correct, right? I mean, at this point, factoring isn't just something you do for the sake of factoring, right? I mean, factoring we're doing so that we can find the zeros, so that when we do the reciprocal, we can find the restrictions. Okay, so you factor it, you check it. You write the, and you write the restrictions. Okay, I'm gonna have to make a mistake on something. All right, so I want x squared plus 4 to equal 0, which means that x squared is -4. I can't square something and end up with a negative, right? No, you can't factor it. It's a sum of squares. You can't factor those. Where's the NHL ref? You can't do that? No games till, well, what, Flames play on Wednesday, right? My kid was actually quoted in the paper the other day. Really? I'm reading the paper and there's my kid's name. It's like, what? Yeah, so you think about it, right? X squared plus 4. What do you know? Well, I know that x squared is always positive. What's the absolute lowest value you can get for x squared? 0, right? Because 0 squared is 0. Okay, I can't get x squared to be negative. So the lowest possible value for x squared plus 4 is 4. Okay, and that's fine, right? I mean, you can divide by 4. There's no way to get this to be 0. There are no restrictions, right? Now what that means, and if you think about it, if you graph this, what is it? It's the graph of x squared, and then what happens to it? It's moved up 4. So you think about the graph of this thing, it's this. Right? Hey, there's no zeros there. Right? It's there. Okay? So that's what the graph looks like. So when we do the reciprocal, right, this is what we're aiming for a bit later on, right? What's the, here, we're later on. Seriously, I haven't actually looked through this stuff. I mean, I've done it a few times before, but that was like a year ago or something. So. All right, what if you want to draw the graph of the reciprocal of a function? So if f of x is x minus 2, what kind of a function is that? Linear. Then write the reciprocal of f of x and state all the non-permissible values. Okay, so what's the reciprocal? 1 over x minus 2. What's the restriction? X cannot equal 2, right? Okay, reciprocal, nice and easy, right? We just write it as 1 over. Complete the following table of values. So one of the best ways to start this whole experiment, right, what we're looking for here, is to actually try it very formally, right? So we're going to plot a table of values for x minus 2. We're going to sketch the graph of x minus 2. We know what that looks like, right? I mean, it's a straight line. It has a y-intercept of -2 and a slope of, what, 1? Yep. And then we're going to graph y equals 1 over f of x, right? Using those values, we're going to label each graph with its equation. So we're going to come up with the points. Can I do this? I think that'll all fit nicely. So let's do this guy in red. So what was the equation? It was like f of x minus 2, right? Okay, so what's minus 2 minus 2? Minus 4. Minus 3. Minus 2. And -1. Yeah, well, somebody changed the 1/2. 1.752. 0. 3 minus 2 is 1, 2. And let's do this in green. So really all we have to do is take 1 over this number, right? So this is -1/4, right? Because we know when you do the reciprocal, the sign doesn't change, right? If it was negative, the reciprocal is negative. -1. Hey, -1, because the reciprocal of -1 is -1, right? So that point didn't change, right? It'll have a red dot and a green dot. -1, what's the reciprocal of -0.5? -0.5. -2. What's the reciprocal of -0.25? -4. What's the reciprocal of 0? Undefined. Okay, well, that's going to be interesting how we're going to graph that, right? So what does it mean it's undefined? Like, how do you... What's the reciprocal of 0.25? +4. +2, +1, and 1 over 2. All right. Sorry? I thought it all fit. So what's 3 and 1/3? Okay, so now in red, I can graph these guys, right? So when x is -2, we have -4. When x is -1, we have -3. When x is 0, we have -2. Actually, all I got to do is just keep going up 1 over 1, right? Throw in a point, even if it's not there. Toss 1 in here. Okay, and we draw a straight line, which I could do with the straight line tool, but I'm lazy, so I'm just gonna sketch it in. And we'll call this f of x. Right, and we're using color, unless you're red-green colorblind, in which case it's like, doesn't look any different to me. However, I'm not, so it does look different. Where are we? So -2, we're at -1/4. Okay, well, this is fairly big, so I could do a decent job of finding a quarter. We're at -1/3, so -1/3 is bigger than a quarter, right? Yeah, a quarter of something and a third of something. So it needs to be a little bit larger, but it's also negative, so it'll go like there. And at 0, we get -1/2. Okay, I think we do a pretty good job of estimating halves. At 1, it's -1. See, so that's an invariant point, right? It's the same on both graphs, right? It does not vary. Oh, I never graphed the one. Let's go back and do this. Wow. That was just a. I didn't do 1.5. 1.5 was -0.5, so that's there. 1.75 was -0.25. 2.25 and 2.5. Okay. Now I got to do the green. And green is actually so 1.5 was -4, and 1.75. Oh, sorry, 1.5 was -2, and 1.75 to be here was -4. And we had some other points, right? 2.25 was +4, 2.25. And 2.5 was 2. All right, what is it, like quarter after? And, yeah. Okay. So, are we ready to graph the green graph?
How do we do it? It's just like 2.
Okay, so what do we do with undefined? So, okay, think about this. As we get closer to 2, so remember it's x minus 2, right? So let's come closer to, as we get closer to 2 from above 2, so we got 0.5, 0.25, so 2.1 will be 0.1, right? And what's the reciprocal of 0.1? Which is 1/10. What's the reciprocal of 1/10?
10.
10. Okay, so at 2.1, we're going to be at 10. At 2.01, which is 1/100th, the reciprocal of 1/100th is 100. So this thing is going to climb pretty quick, right? So what do we do? At 1.7, I got these in the wrong place or something. Do I? No, wait, what? Okay, 2.5 was 2, that's right. Okay, yeah, negative. So these guys are going to climb pretty quick, right? So we're going to get something, oh wait, I haven't even finished graphing this. So 3 was 1. There's another invariant point, right? 4 was 1/2, and 5 was 1/3. So this guy's heading down, right? So you think about what happens. Well, x minus 2. When x is 1,002, right? Way out there. 1,002 minus 2 is 1,000. The reciprocal of 1,000 is 1,000th, right? So it's getting really small. So as we go down here, these guys are getting smaller and smaller and smaller. Now, question, will they ever get to 0? No. And as we go this way, these guys are getting really large. Okay? Now, if we go the other way, what's happening? These guys are getting really large negative, right? So think about it, they're just below 2. So let's say 1.999. 1.999 minus 2 will be negative 0.001, aka -1/1000th. And the reciprocal of -1/1000th is -1000, right? So this guy goes down here like this. And as we get really large negative numbers this way, say -998, -998 minus 2 is -1000, and the reciprocal is -1000. So here is your reciprocal function, right, in green. Yeah, it actually looks like the graph of a reciprocal function. You're going to come to know it as the graph of a reciprocal function. Okay. Let me ask you one thing. X minus 2. If you're thinking about transformations, what does x minus 2 do as a transformation? So if I said y equals x minus 2 quantity squared, you would say, hey, that's a quadratic, but it's right 2. Yeah, so when you subtract 2 from the x, you move it to the right 2. So this is the graph of 1 over x moved to the right 2 units. Okay? You don't have to know that yet, but it's kind of an interesting little thing. Okay, notice that the graph of y equals 1 over f of x is getting closer to a vertical line and a horizontal line. A horizontal line, a vertical line. Bless you. These lines are examples of asymptotes. Word for the day, asymptote. A line is an asymptote to a curve if the distance between the curve and the line approaches 0. Note, approaches 0, can't be 0, right? So you can never hit that line, right? We can never get here, right? Because what happens when x is 2? X minus 2 is 0. We have 1 over 0, which is undefined. We can get as close to 2 as we want, right? You can go 2.000000000. You can say that for like half an hour, and then 1. You can get close to it, and we will get very close to this line as we climb, but we will never touch that line, right? We can't. It's undefined at that point. And we can get as close to 0 as we want, but you can't get to 0. Okay? So those lines are called asymptotes. So the equation of the vertical asymptote is x is equal to 2, right? Yeah, vertical line has the equation of the form x equals, right? What is significant about this value of x? What can we say? The reciprocal function is undefined. What's the equation of the horizontal asymptote? Something equals 0. Y equals 0. Yeah, exactly. Right, so when we want an equation, it's got to be equals, right? So you can't just say 0, and you can't just say equals 0, right? It's something. So horizontal lines are always of the form y equals, and vertical lines are always of the form x equals. Okay, so if we have a vertical asymptote, it's going to be x equals. Horizontal asymptote is going to be y equals. We're actually doing this stuff right now in Math 31. We're doing curve sketching, right? So it'd be like sketching that curve, okay? Which you could say, well, we just draw a set of values and do that. We do more complicated stuff, but there's characteristics of this that you'll learn, right? If you go on and do Math 31 and curve sketching, you need to know about these asymptotes, right? I need to know, well, when is it undefined? And then, more importantly, okay, so it's undefined when x equals 2, but then what happens? Is it undefined as in it goes up like that? Or is it undefined as in it goes down like that? And how do I know which one's happening? State all invariant points and highlight those points on the graph. So what are the invariant points? 1, -1, and 3, 1. Okay, so points, remember, 1, -1. Point is an ordered pair. An ordered pair is a set of numbers with a comma in between enclosed in parentheses. And we are to highlight them. I suppose I could dig out a highlighter here. Is there a highlighter? I don't know. I could draw yellow.
It's not yellow.
That's not yellow. Yeah, I know. Whatever. There, highlighted, right? Invariant points. Okay, so those are the invariant points. Right? You may have to highlight them on your graph, right? Or just show, just sort of say this is an invariant point. Okay, if f of x is x squared minus 2x minus 3, then write the reciprocal of f of x and state all the non-permissible values. Okay, what's the reciprocal? Okay, what are the non-permissible values? Okay, so how do we get those, right? Well, we need to solve this, right? We got to set it equal to 0. So, okay, so we say, well, all right, well, what do I need? I need the non-permissible values. What are those? Those are the values of x that make it 0, right? So I solve for x squared minus 2x minus 3 equals 0, and I get x equals negative 1 and 3. Those are the non-permissible values. The restrictions are that x cannot equal negative 1 and 3. Okay? And generally speaking, it's, you know, we really want to do the restrictions, right? Because you're going to say, what can't x be? So, but here, we've done both, right? These are the non-permissible values, NPVs, right? And these are the restrictions. Complete the following table of values for f of x is x squared minus 2x minus 3. Sketch the graph of and label each graph with its equation. All right. So, okay, I'm going to have to shrink this a bit if I want to fit it all. View. Zoom, what, 150? Do it. Nope. 125. Yeah, that'll do. Okay. Oh, shoot. At least they gave us the x squared minus 2x minus 3, right? So what do we have to do? We just have to go 1 over. 1 over 2.3. That's kind of not exactly the nicest of numbers, right? So let's give ourselves some decimals because they'll be easier to plot, right? So 1 over 2.3 and 0.4. This is 1. It's 2.5. 5. Okay, so I have filled those values in using decimals and showing some. I mean, the second time we're doing 1/5. I'm not writing 1/5, I'm just going with 0.2, right? So now, you want to graph those. I'm going to pause this thing, and you got to sit down and graph it yourself. Right? I know, right? You got to do this because you got to realize this is painful, and there must be a better way. Okay? But you don't get to do the better way until you've done the way. So do the way. Hey, wax on. Okay, so I've put the dots down, the points down for the original function, which was x squared minus 2x minus 3. I'm just going to join those, right? So it's a quadratic. So it's a nice parabola. It's continuous, right? I mean, I don't have to worry about, you know, I do have to worry when I'm graphing the green function here, right? Because we have 2 places where it's undefined, right? Which is where? Well, that's where the original function is 0. The original function is 0 at negative 1 and 3. Those are our restrictions, right? And we know that our restrictions then are going to be asymptotes. So what I'm going to do actually is sketch in. So see how that's 0? So I'm going to draw an asymptote line. So all I'm going to do is just put a dashed line running down where x is negative 1 and where x is positive 3. Right? Because I know that those are asymptote lines. Okay, now I can start graphing these guys. So I'm just going to pause and put the points. All right, so just to say, if I know that point is 5, then I know the reciprocal is 1. Like if all they gave me was the graph, if I didn't have the table, because I am working from the table, but if I know that's a 5, then I know that's a 1/5, right? And I've just got to kind of estimate that. I'm not really too sure of these other points, but I know this point is positive 1, its y value, so the reciprocal is going to be positive 1. And then I'm going back to here to use this, right? And I can see that at negative 1 it's undefined, but what's happening, right? It's doing this. And I've drawn in the asymptote line at the restrictions, right? Because I know that x cannot be negative 1. I can't get a negative 1. Okay, now if I ask myself, well then, what's happening as we go this way? Well, if we look here, what's happening to the red values? What are they doing out here? They're getting bigger. So then the reciprocal is going to get smaller, and it's going to approach 0, right? Is it ever going to reach 0? Unlike some of the marks of the people over here, which will closely approach 0. So will this curve. It will approach 0 as well. Perhaps not as fast as the marks will, but who knows. Okay, so as the red values get larger, right, as these values get larger, then the reciprocals get smaller and approach 0. So that's what's happening in this little branch here. Now we kind of move into the middle. Right? So into the middle is, so what's happening in between the undefined stuff, right? Well, let's just say I knew that was negative 4, so what's the reciprocal of negative 4? Negative 1/4, right? So I want to kind of graph negative 1/4. Now I know that from here, I've actually written it down, but if all I had was the graph to work from, and this point is negative 3, so its reciprocal is negative 1/3. Well, 1/3 is bigger than 1/4. And this guy is negative 3, so it's also negative 1/3. Okay, now I got to go to the table in here because I got to see what's happening. So at negative 0.9, right? So as we approach negative 1, but from the other side, right? From above, right? So this is approaching negative 1 from below, right? From smaller values, and we can see it climbs up. So I approach negative 1 from above. Right, from a larger value, at negative 0.9, we get negative 2.5. So this value is negative 2.5. That's at about there. At negative 0.7, we're at negative 1. Oh, well, that's an invariant point, right? If the y value of the original function is 1 or negative 1, then the y value of the reciprocal is 1 or negative 1. Okay, and that's happening here, right? This point will be an invariant point. And what happens as we get close? So at positive 2.5, we're at negative 0.6, so that's there. And at positive 2.7, we're at negative 1. At positive 2.1, we're at negative 2.5. So what's going to happen as I get closer and closer to 3? Are these values going to get larger or smaller? Larger negative values, right? And you could kind of think of that as smaller. So here's what happens in the middle, right? We do this. And then these guys go, whoops, it doesn't curve in. Okay, it's going to approach the asymptote line. Which I'm going to re-sketch. All right, what happens on this side? Same thing, right? So as I get closer to negative 1 from above, right, as in negative 0.99999, right, these values are going to get really large, but really large negative values. So that's what's happening in between here, right? Now, what happens to the right here? These values get really big. So starting here, these values are getting larger, so what are the reciprocals doing? They're getting smaller. These values are getting really small. So what happens to the reciprocals? They get very large. And so we do this. Okay, so that's what the graph looks like. And part of that I did from graphing points, and part of that I did from saying, hey, let's just look at what's happening here, right? Which is, I suspect, what we're going to do next, is take a look at a graph and say, hey, what's happening here? And what you want to do is get to the point where I give you a graph, you can sketch the reciprocal, right? And you're just going to say, all right, there's a few things I have to watch out for. Okay, first, any questions on this, right? Is everybody good with this? Okay, so that's what that looks like. Just to show, right? I mean, because, here, let's do this. So here's the graph, right, using decimals. I like decimals because we get a nice scale. We can see the points nicely. You cannot use decimals on an exam, though, right? So keep in mind, you got to know how to use your calculator. And now I want to graph. I don't know if I could do this. Let's see if I could do this. 1 divided by y. Okay, I can't do that. Where's the ref? You can't do that. What is it? X squared minus, oops, don't, oh yeah, minus 2x minus 3. Okay, does that look like what we have?
Yeah.
All right. So, yeah, it looks nicer than what we have. Yeah, well, it's because it's, you know, it is nicer than what we have. What do we know? We know this is -4, right? What do we know about this guy, right? It's -1/4, -0.25. Okay? All right. Before I get way off topic, which I am wont to do, let's move on. So the graph of y equals f of x has two vertical asymptotes. The equations of the vertical asymptotes are? No, they're equations. X equals, and what is significant about these values of x? They make f of x equal to 0, right? And so make the reciprocal undefined. The graph of y equals f of x also has a horizontal asymptote. What is its equation? All right, I think we can see it here. What's the equation? Y is equal to 0. State all invariant points and circle them in blue. Okay, so there they are. Now it's easier to state them from the thing there, right? The table. So what are the invariant points? What's the first one? -1.2 and 1. What's the next one? Sorry, what? -0.7, -1? All right, I'm just reading them off. What's the next one? 2.7 and -1? What? Oh. What's so funny? Why are the keys jingling? 3.2 and 1. Okay. Questions, comments, concerns? What's next? Oh, conclusions. We must almost be done. Are we like almost done?
No, there's another page.
Oh, there's another page. Wow. It's like 2 pages. All right, then we better get going. So the point xy that lies on the graph y equals f of x is transformed to the point. So what's the new point? Does the x value change? No. What happens to the y value? Becomes reciprocal. What's the reciprocal of y? 1 over y. So the point xy becomes transformed to the point x comma 1 over y, right? If y equals f of x is a continuous function, then y equals 1 over f of x will have a vertical asymptote wherever. So when do we get vertical asymptotes?
X equals 0.
Not x equals 0. F of x equals 0. So wherever the original function is 0, we got a problem, right? You can't go to 1 over 0. The invariant points for the transformation y equals 1 over f of x are the point where the blank coordinates of y equals f of x. So which coordinates? And what are they? The y coordinates, right? Yeah, take a flyer. You get a 50-50 chance. Where the y coordinates are what? 1 or negative 1. Okay? So as much as it looks like there's still a ton of stuff to do, it's actually going to go fairly quickly. Graph of y equals f of x is shown below. Sketch the graph of y equals 1 over f of x on the same grid. All right, so I'm going to shrink this a smidge so we can, let's go to 150. All right, here's what you're going to do. You are going to say, when the original function is 0, what are we going to have? So here's the original function. It's 0. What do we have there? We have a vertical asymptote. So we are going to find the original function is 0. We are going to sketch in vertical asymptotes. Okay, so that's step 1. Say, okay, the original function is 0. The reciprocal is going to be 1 divided by 0. I can't do that. I'm going to have a vertical asymptote. Next thing you're going to say is, I know that there are invariant points wherever y is equal to 1. I'm just going to go along the line y equals 1 and say, hey, here's an invariant point. Here's an invariant point, right? Because 1 divided by 1 is 1. And I'm going to do the same thing at negative 1. Say, here's an invariant point. And here's another invariant point. Right? So the first thing you do is you find the zeros of the original function, you sketch in vertical asymptote. Then you plot the invariant points, right? Because you know they're going to be on both. You're now going to plot the reciprocal of any points that you can easily find. So for example, this is negative 8. The reciprocal of that will be negative 1/8. So I'm going to plot a point at negative 1/8. This is the point 4. The reciprocal of 4 is 1/4. So that's going to do that, right? This is 2. That's going to be 1/2. Gives me an idea as to what's happening, right? This is positive 2 here. The reciprocal is going to be 1/2, and this is positive 4. The reciprocal is going to be 1/4. Lets me know that, all right, what's happening out here? I'm going to be going down like that. Why? These values are getting larger. Reciprocal values get smaller. Invariant point. These values get smaller, but they are positive, right? What happens when you take 1 divided by a really small positive number? You get a very large positive number. So we're going to go up here. And same thing's going to happen on this side, right? These values are getting larger, so their reciprocals are getting smaller. These are smaller positive numbers, so we get larger positive numbers, right? Reciprocal is going to be larger. All right, so what's happening in the middle? Well, I got a couple of points here, right? We could also do the 4 is 1/4. Well, let's look for 2. So at 2, negative 2, it's going to be negative 1/2. And negative 4, it's going to be negative 1/4. There's also going to be happening on this side, right? Negative 2, that'll be 1/2. And negative 4, that's 1/4. And we come up to an 8. So this in between here, it's going to do this little climby thing, right? And then these values are just, this is a little off here. So that's as high as it's going to get, right? And then it's just going to kind of stay and and do that, and same deal, right? All right, so as we go, this is the invariant point. You're pointing in the wrong direction. This is the invariant point. These values are getting smaller, right? So as I go from this invariant point this way, these values are getting to be smaller, 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 negative. What's going to happen to the reciprocals? Larger, 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 negative. So what are we going to do? We're going to drop down the asymptote, right? We never touch it. I just can't draw. Okay, so that's what's happening, right? So I give you the graph. You just have to go through like a 4-step process, right?
5.
I knew there's a reason I printed the answers off, right? It's like there's no way I can come up with the 5 steps if I have to do it on my own. Okay, steps to graph the reciprocal. Okay, so step 1. Find where the original function is 0, right? That's the x-intercepts, right? So you're going to draw vertical asymptotes through the x-intercepts of the original function, right? Y equals f of x. Okay, because the x-intercepts are where y is equal to 0, and then if you try and do 1 over y, you can't do 1 over y, right? So that's the restrictions, those are the restrictions for 1 over f of x. All right, so first step, just go along the y-axis, right, and just say, oh, there's an intercept, draw a vertical asymptote. Keep going, there's an intercept, draw a vertical asymptote. Okay, that's step 1. Step 2, plot the invariant points. Right, that's where y is equal to plus or minus 1. Okay, so you're going to plot the invariant points. Y is equal to plus or minus 1, plot the points. Plot the reciprocal of all of the max min points and any other nice points. Okay, so plot the reciprocals of any max or min points. Right? So if you look back here, amazingly the smartboard's behaving today. Right? There's a minimum point, negative 1/8. That would be the maximum point, right? Sorry, negative 8. This would be negative 1/8. So plot the reciprocal of any max min points and any other key points. Right. So if you can identify, hey, that's 2, a y value of 2, then it's going to be a y value of 1/2, right? Just gives you some nice points to work with. Draw a smooth curve through the points. There's actually only 4 steps. Draw, or at least the last, whoever filled in what I'm working from. Draw a smooth curve through the points. Do not cross the asymptote lines. All right, I mean, if you come kind of, I mean, it's tough to draw and you're sitting there with a pencil and that, but do your best, right? I mean, but if you obviously cross the line, then I'm gonna have to deduct marks there, right? And obviously crossing the line would look something like this. You're drawing this and you just sort of go like that. All right, nah, incidental crosses, like I'm trying to go up there and it acts, whatever. I mean, we've got the idea, right? But okay, what do we do again, right? You look at the original graph and you say, there's a 0. So I'm gonna have to plot a vertical asymptote. You look at the original graph, you go along the line y equals 1. And you just put a dot wherever the curve crosses. You go along the line y equals negative 1. You put a dot. You find any key points. That's a minimum, right? It's going to make a maximum there. Okay? And then you sketch along the asymptotes, right? So the idea just being to say, what's happening on the original curve And then what happens with the reciprocal? Apply the reciprocal on any other key points. Actually, no, I guess we could throw in a, let's make that 5. And then 4 would be, well, okay, I'm going backwards, but you know, you can, so 3, 4, 5. This would be, you know, as you move along the curve. So as you're moving along the curve, as you move along, y equals f of x, to larger values, you make smaller values. Right? And as y equals f of x gets smaller, then y equals 1 over f of x gets larger. Right? So that's just the idea of, you know, okay, these values are getting larger, so the reciprocals are getting smaller. These values are getting smaller, they're going down to 0, so the reciprocals are getting larger. Right? And you just do that along each of the lines. All right, so next, graph y equals fx, use the steps above, and your conclusions about vertical asymptotes, invariant points, reciprocals, numbers, sketch the graph y equals 1 over f of x, where indicated, state all the invariant points and the equations of horizontal and vertical asymptotes. Okay, this is it, right? Hey, you just think of this as like 30-1. Every day in 30-1 is just like this. Okay? Let's go to what? 125. Okay, so we have a couple of straight lines, right? So here's what we're going to do. Okay, this is where you've got a 0. So what am I going to draw here? You can draw a vertical asymptote, right? Next step is to draw invariant points. So where is y equal to 1? Move along this line. Move along this line. When you find a point, plot it. It's invariant. All right. As these values get large, what happens to these values? They get small. So you do this. As these values get smaller to 0, these guys get larger, right? Now I could do this. This is like a half, so I could maybe say -2. Right? And make that smooth. Okay. Here's my invariant point. These guys are getting larger. What happens? The reciprocal values get smaller, right? 10 to 0. These guys are going down to 0. They're getting smaller. So these guys get larger. Right? Done. Okay. Graph. Vertical asymptote is where? Horizontal asymptote. Invariant points. 0, 1. And 4, -1. Okay, any questions on that one? So you do the next one. All right, here's your chance. Did the exact same procedure, right? You got the 5-step procedure. Start off with your asymptote line. Vertical asymptote, right? Start off with the vertical asymptote. Plot the invariant points. Okay, your vertical asymptote. Plot your invariant points. Sketch the graph. You could do other points, but on this graph you don't really need to bother, right? So what's it look like? These guys are getting larger. Reciprocals of that will get smaller. These guys are getting smaller, going to 0, so we're going to climb up the asymptote line. These guys are getting smaller. They're going to 0, but they're negative, so we're going to get very large negative values. These guys are getting large negatives, so their reciprocal is going to be small negatives. Vertical asymptote. Remember, the asymptotes are lines. Lines have equations. Invariant point, what do we got? -3, 1, and -4, -1. Okay, any questions on that one? No. Is that what you got? Cool. Okay. This is a little tougher, but you know what these look like, right? You have examples of them. Okay. You want to get a few more points, though. So let's start with our asymptote line. Asymptote line. Invariant points. Go along the line y equals 1. Look along this line. Just plot these points. Go along the line y equals -1. Plot these points. Find some other points. Well, okay, I've got a maximum there a little above 6, so I'm going to have like 1/6. I've got like 4, so that'll be like 1/4. I've got 2, that'll be like 1/2. Got a 4, that's a quarter, and I got a 2, that's a half. So I can see what's going to happen in the middle, right? I'm just going to get this idea of, okay, so these guys are getting smaller, so we're going to climb this asymptote line. Climb this asymptote line. We're just going to come down here and kind of flatten out like that, right? That shape. And then we know what these guys look like, right? These are getting to be large negative values. They're going to get small negative values, tending to 0. These guys are going down. They're getting smaller, smaller, smaller. The reciprocal is going to be larger, 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 but it's negative. Okay, and the same thing is going to happen on this side. Okay, there's my graph. Okay, vertical asymptotes. -3. X equals +4. Horizontal asymptote, y equals 0. Invariant points. Oh, wow. The numbers aren't so nice here. I'm going to look off here. -3.2 and -1. 3.8 and 1. -2.8 and 1. And 4.2 and -1. All right, so I mean, all you can do for the invariant on this particular case is just come up with a best guess, right? Okay, any questions? We'll do the last one together because it's a little bit special, or it's more special. It's actually a really neat shape when you see it, right? You're gonna go, wow, that's kind of a really neat shape. Like, it's not like one of these guys, right? Because, why isn't it like one of these guys? There's no vertical asymptotes, right? So all we do is say, huh, okay, no vertical asymptote. There's no invariant points, right? Invariant points would be on this line, right? This line. No invariant points. Or this line. No invariant points. Okay, so there's no invariant points, there's no asymptote. So what can we do? Well, what's the reciprocal of 2? Half. Okay, what's happening to all these values from 2? They're getting bigger. So what happens with their reciprocals? They get smaller. So this is a half and this is 1/4. So that's going to be like halfway. And this is a half and this is a quarter. Okay, so it's going to be like that way. And this is what the graph's going to look like. All right, I'm going to go through that point there. Now you could graph this, right? We know what this graph is, right? What's the equation of this graph? It's x squared plus 2, right? Okay, how do I know? Well, it's moved up 2, and you go over 1, up 1, so it's just 1x squared. The x squared is positive, so it's 1x squared plus 2. So if we go in to graph this, right? So x squared plus 2. That's the original. And then y equals 1 over x squared plus 2. And you got that point, right? I mean, that's the point 0, 2. That's the reciprocal. It's kind of an interesting shape, right? It sort of does this little thing here, right? It sort of goes like that before it changes and goes like that. Okay. Now, that whole idea of this idea of this happening like this shape, when you do calculus, you'll learn why it makes that particular shape like that, right? Why it's shaped exactly the way that it is shaped. For now, we could just take reciprocals of values and stuff, but you know, just this kind of the way the shape is shaped like it is, and where it sort of changes, because you notice it sort of goes like this, and then it, well, okay, you can actually see exactly what it's doing. Right? I mean, it's coming down, and then it's sort of going like that. Like it's sort of changing shape a bit, right? You think about it, if you were driving along that line, you would have to make a steering correction at some point, right? If you're driving along like that, and I got to come back to the left, right? I'm kind of pointing my wheels this way, and then I got to sort of straighten them out a bit, right? Got to change direction. All right. Oh, so we need, what do we need? Vertical asymptote, none. Horizontal asymptote is y equals 0, and the invariant points are none. All right, is there more? Yeah. There is, isn't it? It keeps going. Good. This is just like a get you ready for next year, right? Okay, so what do? We find the zeros, we draw vertical asymptotes. We find the 0, we draw a vertical asymptote. We go along the line y equals 1, we get the invariant points. Invariant point, you can do those in red, but invariant point, invariant point. So we're dealing with, what do we got? Like 3 sections, right? We've got the section that's going to the left here, which is kind of 2 sections. So these guys are going down in value, right? Getting smaller, smaller, smaller negative numbers. Their reciprocal is going to be larger, larger, larger negative numbers. These guys are larger, larger, larger negatives, so the reciprocal is smaller negatives. Over here, exact same thing is happening, right? Wow, must have had the thin lines. Yeah. All right. It was doing so well. That's all right. Reviewing is never hurts, right? So at the zeros, you draw in vertical asymptotes. Y equals 1, invariant, negative 1, invariant. Okay, you want to draw the line. These guys are, oh, this ends. This ends at 5, right? Negative 5. So then we get negative 1/5. That ends. These guys are getting larger, so this is increasing, right? These guys are getting larger, these guys get smaller. These guys are getting smaller, they're going to 0, negative, so we drop on the asymptote. These guys, small positive, that's 3, this is going to be 1/3. Okay, so we know what this looks like, right? Does this, does this. Okay, we have experience now, we know what this is going to do, right? In between here, that's what happens, right? Because there's a maximum, right? Although, will that be curved? Not so much, right? It's going to be straight line. Kind of a straight line here, right? And then it's going to curve because these guys get smaller, these guys. So we are actually going to have more of a point there. And then smaller, larger, larger, smaller. Vertical asymptotes, where were they? X equals negative 3. X equals 1.5. Horizontal asymptote, there's 1, right? Like this isn't an asymptote over here because this ends here, but this is an asymptote, so it is y equals 0. Yes, I know. And invariant points, what do we got? Negative 2, 1. 1, 1. Negative 4, negative 1. And 2, negative 1. When you're doing invariant points, what are you going to see in the second position? 1 or negative 1, right? That's your invariant point. All right, what is there? One more? All right. Now, the graph of a reciprocal function of the form y equals 1 over ax plus b, where a and b are non-zero constants, is shown. What do they want us to do? Well, we made it through most of the thing. All right, what does it say? Sketch the graph of the original function. So, how do we go from a reciprocal function back to the original function, right? So we got to think about kind of reversing point. All right, so what happens where you have a vertical asymptote? The original function has a 0. So we're going to say, all right, it looks like there is a vertical asymptote at 2.5, which means we're going to have a 0 at 2.5, right? Now, this is a straight line, right? Ax plus b, which means the original function was a straight line, right? We have 1 over ax plus, hey, it's back. We have 1 over ax, so there's a vertical asymptote here on the reciprocal, which means the original function has a 0. This is a straight line, right? So it has a y-intercept. So first, let's do the invariant points. There's one here, and there's one here. And then what does it take to draw a straight line? 3 points, more than enough to draw a straight line, right? So I can draw a straight line. Just not a great straight line. So let's do this, right? Since I have these 2 points, I know what the slope is, right? 1, 2, 1. All right, so hey, let's be smart about this. Let's be smarter. So here's this, and here's my 2 points, and it's a straight line, 1, 2, 1. So the slope is positive 2. So here's some more points, and so the slope is go down 2 and left 1, right? That'll give me the y-intercept. And down 2 and left 1. Okay, so what's the equation of the original line? I don't know if it's asking that, but the slope is 2, and the y-intercept is minus 5. So did it ask for sketch graph, the original function? Yep, write the... Okay, so we have these 2 points, right, which we know for sure, right, because they're invariant. So the slope is, right, so m is equal to plus 2 over plus 1, which is 2. And using that slope, go down 2, left 1, down 2, left 1. The y-intercept is negative 5, giving us the equation of the original line. All right, so there's a vertical asymptote on the reciprocal, which corresponds to a 0 on the original. There are invariant points. There were 2 of them. From those 2 points, we got the slope of the original line. And we just put it together. Did a reasonably accurate graph of the original line, which gave us the equation. Okay, so sketch, right, done, right?